This is Professor Darif Seitz. This video shows how to create a histogram chart using Microsoft Excel. This spreadsheet has 3 tabs. First is a frequency distribution. That's the first step. Start with your data. Here in the first column, you see the data set. It's 30 items in the data, and it's sorted. It needs to be sorted so that you can easily find the frequencies as part of this frequency distribution. The blue cells, you have to enter the data or copy and paste it. Notice that there's only a relatively few blue cells. All the rest are calculated with formulas and functions. Before we go through more details on this tab, let's look ahead at the chart, a histogram, what it looks like. It's a column chart showing intervals of data values that are all the same size, and they're right next to each other. There's no gaps between them except a little tiny bit to show a boundary there. And on the vertical scale is, in this case, the frequency. And so it allows you to see the distribution shape of the data visually. Going back over here, we begin with the number of classes. You have to decide in this data how many classes do you want to show. Over here in this chart, there's 7 bars for 7 different classes, and each class is indicated by an interval involving class limits, a lower limit and an upper limit inclusive. Going back here, lower limits, the 59 is a formula. It's the minimum value in your data. If your data set, which it probably will be larger or smaller than this one, if you want to reuse the spreadsheet after you copy your data in and find out what row it goes to, you'll have to edit this range. Instead of 31, it'll be whatever fits your data. Don't forget that point. But as I was saying, you have to decide the number of classes that you want to use. This example here uses 7 classes. That's more than enough. Typically, it wouldn't be more than that. So that's a given. You have to enter that. Next, there's a range, and it uses the maximum value minus the minimum value and does that with a formula. The max function on the data set minus the min. 391 is the range. And the class width is calculated next in this spreadsheet. Takes D11, which is the range, divides it by D12, the number of classes, and rounds up. So no matter what fractional decimal points are there, it's going to go up to the next integer level. If you had 55.2, it's going to go up to 56. Then from there, the first upper limit, this is the first class, second class, there's 7 classes here, 7 rows. The upper limit is the lower limit plus the class width minus 1. The subsequent lower limits are always class width larger than the one before them. And the same pattern follows with the upper limits. They're a class width greater as you go down each one increases by 56 in this case. Part of the frequency distribution is to find the midpoint of each class, and the standard midpoint formula, sum of the endpoints divided by 2. That is done for you here. And in all these formulas, the only two that involve the size of the data is this first one here for the first lower limit and the range as well. So those are the only things that need to be changed if you have a different size data set, which you probably will. Lower and upper boundary are alternative interval endpoints that can be used to enclose the data. They're calculated by subtracting half of a unit from the lower limit for the lower boundary and adding half a unit to the upper boundary. Traditionally, histograms can show lower and upper boundaries. I prefer to show lower and upper limits in mine. They can also show midpoints. It's up to you what you want to show. But this spreadsheet does everything that you would want to have right here. So the lower and upper boundaries are all calculated. The next thing you have to calculate, or you have to enter manually, they're blue, is the frequency of each class. That's easy to do since they're sorted. 59 to 114, start here and drag. Takes us right through there. Those are all in that class, in that interval, and there's 5 of them. If there was too many to count, you look down here in the status bar, it shows you how many you've selected. Count 5. The next class is 115 to 170, so you go to your next data item through 170 right here. That's 8. So you get the pattern of how these were entered. This is a sum of the frequencies. There's 30 data items. This sum should match that. Relative frequencies, you take the frequency, see the formula here, and divide it by the total number of items, which is $H $9. That means absolute positioning of this where this 30 is. That gives you all the relative frequencies, which are percents of the whole. They are they should all add up to 1, which they do in this case. Cumulative frequencies, you start with the first one, 5, and then as you go down, you're adding like a snowball effect. 5 and 8 is 13, 13 and 6 is 19, and it's also sometimes of use in a frequency distribution. So here, this spreadsheet will save you a lot of work to do this all by hand. Every time you want to do this would be not fun at all, very stressful, error prone. You wouldn't enjoy. It would detract from the purpose of this, is to get to where you can see the distribution and analyze it and compare it and things like that. Moving on to the histogram charts now that are based on this data. The first tab, I repeated the data here, of course, in Microsoft Excel. You can refer, there's a way to refer to data in other tabs, but I wanted everything right here. So here's the data. And this chart here does not use the title of the header up there, but uses the data. And the chart type is a histogram in the statistics group of charts. And Microsoft Excel has a lot of calculations behind the scene. Essentially, it tries to reproduce behind the scenes a lot of what takes place here in this frequency distribution. However, it doesn't round up for the class width, which is a standard practice to do that, which means that it's not quite meets my standards of how I would want it. Once you have inserted it, of course, you have various chart elements that you can select. And if you look at the axes here, you go to more axes options. There's two options over here that are fundamental in Excel's histogram. You can either enter the bin width, which is equivalent to the class width, or you can enter the number of bins, the number of classes. Or you can just say automatic, let Excel figure out how many classes there are, and it does everything. I tried different options here. I started with the bin width. I put 56, which is what I wanted, and it did not give me correct inclusion of the endpoints. It was one off, probably because it doesn't round up, and it has a lot of other calculations that are all related. So then I went to 7 as the number of bins, and it had a lot of decimal points, and it was at an angle. To fix that, you go down to the number down here. I changed the category from general to number and put the decimal places at 1. And having that, there were still rather wide intervals, and they had to stagger them like this. And to me, it's a little difficult to really read, and it doesn't follow the standard of using like class boundaries, which is 0.5 off on either side. So I wasn't content with that chart, although I wanted to show it here. Note that it does use 7 bins and decimal place is 1. Instead, going to the third tab, I used a standard 2D column chart of a clustered column type. And those column charts normally have big gaps between the bars. And in a histogram, there's not supposed to be any gaps. All the bars are supposed to be the same width and no gaps between them. So this chart, the data that I entered is over here, limits and frequency. For the limits, I entered interval notation of the class limits with the square brackets indicating inclusion. So in the first class, 59 through 114, inclusive of those endpoints. And with the commas and the square brackets, this looks like text labels to Excel, and they're just put on the bars. And that's what I wanted. Simple labels down there like that. And then the other tricky part of this was how to get rid of the gaps between the bars. And it turns out that there's a format data series gap width. And to get to that, click on the chart, click on the bars, all the bars. Don't just click one, but click till they're all highlighted. And then when you right-click the mouse, down here is Format Data Series. And over here, there's a gap width. It was originally much higher, and I changed it after some experimentation to 2%. And that gave me these nice little fine lines. And I also added data labels to these so you can see very quickly without having to figure out where they hit the vertical axis over there. So bottom line, Microsoft Excel allows you to set up spreadsheets like I've set up here, where you can quickly and accurately take data, get a frequency distribution and a histogram that you can then use in a document or for a PowerPoint or whatever. And now you can not spend all your time just doing what seems like mindless calculations, but looking at things and studying relationships and trying to understand. And that's the purpose behind statistics, is to see what's really going on in terms of relative frequencies of things.